All right, this video is for trig inverses, evaluating composite inverse statements. And I want to just take a moment and review for you when we've done composite functions before, or also sometimes called composition of functions. This here is a regular equation, y equals 3x plus 5. I can also write this in what's called function notation like this. F of x equals 3x plus 5. This does two things for me. It tells me, it names the function for me, f, and then also tells me the independent variable x. And if you recall, if I write something like this, f of 2, the x has been replaced by 2. I have substituted x with 2 here in the function notation. So that means everywhere I see an x in the equation, I'm going to replace it with a 2. Now, this is an integer, but I can substitute algebraic expressions as well. So for example, if instead of 2, I had 2x, well, that just means whatever's in the parentheses, the 2x, now gets substituted in to the equation where the x is. And not only does it not have to be an integer or an algebraic expression, I could substitute an entire other function in here as well. So let's say I had this function, g of x equals 6x squared. And then if I write this notation, I'm now taking whatever g of x is and plugging it into f where the x is. So g of x is this entire expression, so I would have 3 times x. I'm now substituting x with the 6x squared. And this right here, when you take a function and plug it into another function, this is a composition of functions. And we're going to be doing that today with inverse and regular trig functions. So that is our goal. So if you see this notation right here, a function inside of a function, I want you to recognize that over here, a function being evaluated by another function. And when we do this composition of functions, we're going to be working from the inside out. So what I mean by that is we're going to be doing what's in the parentheses first, and then whatever value we get there, we're going to be applying this other function to that value. So you'll need your unit circle for this lesson, so pause the video and find it if you don't have it. And then I want you to write a few things at the top of your notes for reference. I want you to draw the domain restriction graphs for our inverse functions. These two quadrants for cosine, secant, and cotangent, the inverse functions. And then these two quadrants for tan, sine, and cosecant inverse functions. We also will be working with the reciprocal functions. Cosecant, remember, is the reciprocal of sine. Secant is reciprocal of cosine, and cotangent is reciprocal of tan. Okay, so let's look at this first problem. We're going to evaluate here first the inverse sine of rad 2 over 2. So remember, this means which angle has a sine value of rad 2 over 2. In other words, which angle on our unit circle has a y coordinate of rad 2 over 2. So if you look at your unit circle, I actually have two values with those y values. Here at 3 pi over 4 and then here at pi over 4. So the question is, which or both do I need? And you answer that by looking at the domain restrictions for inverse sine. So I have this little graph here. Inverse sine values are in the quadrants 1 or 4, so that excludes this value and means this one is our only answer, pi over 4. Okay, so that was part 1. So now we are going to replace this with that pi over 4. And now we're calculating cosine of pi over 4. Now this is a regular trig function. It is not an inverse. It does not have the -1 written above it. Therefore, we do not need to take into consideration these domain restrictions. We can just go to our unit circle and find pi over 4 and read the cosine value. So at pi over 4, the cosine value is the x coordinate there, which is rad 2 over 2. Okay. Now on this problem here, inverse tangent, tangent, kind of feels like these should just cancel each other out and leave me with 5 pi over 6. But we're going to work this one step at a time and see that that actually ends up giving us a different answer. Because the domain for tangent is not the same domain as inverse tangent, because we have the restrictions. So let's start by doing this one first and this one second. So this is not an inverse function, the inside tangent. So we can just read this off our unit circle. We're going to find 5 pi over 6 right here, and the tangent value there is negative rad 3 over 3. So I'm going to substitute that value in. So this has been replaced with its value, and then I'm going to bring down the next function and do inverse tangent of this value. So this is asking me which angles have tangent values of negative rad 3 over 3, and this time we have a domain restriction. It needs to be in one of these two quadrants for inverse tan. So when I go to my unit circle, there's two places where tangent is negative rad 3 over 3. This one that we started with, and this one across the circle at 11 pi over 6. But this is the only one that satisfies our domain restriction. It has to be in one of these two domains. So this time our answer is 11 pi over 6, kind of. 11 pi over 6 requires us to travel counterclockwise to here, which takes us outside our domain restriction. So what we need to do is define or identify it as its negative version and go this way. And if we're defining it with the negative version, it's negative pi over 6. So the negative version is the positive, just reflected down. So negative pi over 6 is the same as 11 pi over 6. Okay, I want you to pause the video and try this problem, number 2. Okay, hopefully you had this work. For inside the parentheses, we had inverse cosine of negative rad 3 over 2. So you're asking yourself, what angle has a cosine value of this? So what angle has an x coordinate of negative rad 3 over 2? And this is my inverse cosine domain restriction. So you're going to find two angles with that value, but only one is in one of these quadrants. And that is 5 pi over 6. So that's step 1. Step 2 is to take the tangent of that value. This is not an inverse function. You just find this angle on your unit circle and read the tangent value. So there's 5 pi over 6, and there's its tangent, negative rad 3 over 3. Now this last problem is the first one that has reciprocal functions. So all these other ones were either sine, cosine, tangent. And now we have, not only do we have reciprocal functions, but we have inverse reciprocal. And again, feels like they should just cancel out and leave me with this, and it might, but we still have to do it one step at a time, because the inverse function doesn't have the same domain as the standard function. So we do have to check it out. All right, so this first one, we need to find secant of negative pi over 3. Remember that secant is the reciprocal of cosine. So what we're going to do is find the cosine value there first, and then just take the reciprocal of it. So negative pi over 3. So here's positive pi over 3. The negative version is reflected down here, so at 5 pi over 3. And the cosine of that angle is 1/2. So taking the reciprocal of this flips the fraction to 2 over 1. So this value is 2. And so now I need to take the inverse secant of it. And so this is asking me which angle has a secant value of 2. And well, we don't have secant values on our unit circle. So what I'm going to do is take the reciprocal of both of these. So now I'm trying to figure out which angle has a cosine value of 1/2. And that's in my domain restriction. And we are going to be using the domain restriction for inverse secant, which happens to be the same as inverse cosine. So our answer needs to be in one of these two quadrants. So notice that our original angle is not in the domain restriction. So we need to find where we have a cosine value of 1/2 and is in our domain restriction, and it's this one right here, pi over 3. And that's all for this part of the lesson. There'll be another video for these type problems. They work differently, but on your practice sheet, these are the homework problems that I want you to do that are like these that we just did. Numbers 21 through 30.